Okay, relations. Domain. Domain is the x values. Range is the y values. And a relation is a set of ordered pairs. So 2 comma 0, 3 comma 5, 6 comma 2. That's a relation. Another term for domain is the independent variable, and the range is the dependent variable. This is a relation. It's a set of ordered pairs. It's in the form of a table. You guys have seen a table before. This is a graph. Also ordered pairs, just instead of shown in a table, it's shown in a graph. This is called mapping. This is, maybe not seen so often. So if you look at this, -2 goes to 1. So that's -2, comma 1. And -2, comma 3, because it goes from -2 to 3 as well. So if you have mapping, you could write out all the points. 0, comma -3, 1, comma 4, 3, comma 1. So here you're going to determine what's the independent and what's the dependent variable. What's the x and what's the y. So if we're selling dance tickets, the more tickets sold, the more money there is for decorations. So what's dependent and what's independent? What's dependent on the other thing happening? The more tickets that get sold, the more money there is for decorations. So the decorations depend on the tickets. So decorations are the dependent variable and the tickets sold are the independent variable. That also helps you decide what's going to go on the x-axis and what's going to go on the y-axis. Looks like average is spelled wrong here. All right, average price of movie tickets have increased over time. So what's the independent and what's the dependent variable? Well, time, I'll tell you, is almost always the independent variable because you can't change time. Okay, so the price of the tickets depend on what time we're in. Okay, tickets were a lot cheaper when I was a kid. So the dependent would be the price of tickets, and the independent would be time. Now I want you to look at these graphs and kind of tell me what's going on in this graph. So we're talking about driving to school. What's going on? So he's driving a distance, and then as time goes on, he stops, drives slow, stops, drives slow. So you can tell by this graph, he's going at a pretty rapid speed now, but then he stopped or went really slow all through here. So maybe stop at a stop sign, slow through the stop sign, stop at another stop sign, a little bit faster, but not so much. Here for this one, again, time is our independent. What's going on with our income? It goes up, then it goes up quickly, then it goes up, then it stays the same, then it goes up. So there was a time there where our income was pretty steady, but then it went up fast. Maybe we got a raise, and then it was going up steadily, and then it stayed the same for a little bit, and then it started going up again. Okay, so not necessarily, graphs don't always talk about height. Okay, so you might look at this graph 3A and say, oh, well, he goes up a mountain, then he stays on the mountain, then he goes up more of the mountain. That's not what the graph is talking about. The graph is talking about how the distance traveled driving to school. It's not how high or how low the car is going. All right, so now what I'd like you to do is answer these questions. Okay, let's do all the odd problems. So let's do 9, 11, and 13. I want you to put them in a table, graph them, and map them, and state the domain and range like we talked about at the beginning of the slide. Answer number 15.